Hi everyone, we're here again for another lesson, an area of a triangle. We usually gonna go out of a traditional way of solving it. We're gonna try to solve it in a way that it's new. It's not new, but at least an idea on how we figure it out. Why do you think a triangle is like base times height and we divide it by 2? What is the reason behind that? Okay, let's look at our lessons. So our goal will be to find the area of a triangle using a formula in finding the area of other polygon. So we're gonna use other polygon to find the area of a triangle. But before we start on anything else, I would like to look at these challenging questions that we have for today. Will the area of figure B, this one, be greater or less than the area of a square, this one, with the length of 42 feet? You know, when it's a square, you know the length and the width is the same, so that's why the area of a square will be s to the power of 2. So let's see what you guys got, and I'll show you some answers of my students in a minute. So take your time to solve this problem. You could pause this video and we'll see answers in a minute. So here's one of the answer of my student. If you look over here, she did this she did 30 times 42. This is that part, which is 1260 or 1260. And then she did 12 times 42 divided by 2. This is 42 to that's 42. So she solved for the triangle. And since it is 12 times 42 divided by 2, so gives you 252. Total of 1512. And the area of the square is 42 times 42 is 1764 square feet. She didn't answer the question which one is greater or less than. Oh, she did. Here, the area of figure B is less than the area of the square. It's small. Sorry, I didn't see that right away, but she did say that figure B is less than the area of square. Let's look at one more answer. Alright, so here's another answer. It says 42 times 42 is 1764 square feet. That's for the area of the square, and we solve for the area of figure B, which is 42 times 12 times 1/2, because it's only half of the parallelogram. We got 252, and then we put them together, it becomes 1512. It's less because the area of figure B is the area of the rectangle and a triangle. Figure A is only the area of a square, plus they have the same length. So she didn't really explain, give the details of why they are less or greater from each other. I always remind everyone to explain it while using numbers. So it's very clear that this is greater than that because the total area is 1764 and the total area of B is only 1512. So therefore the area of the square is greater than the area of figure B. All right, now let's move along. So again, we'll see an example on how you can find the area of a triangle just by looking at the shape of a parallelogram. Let's look at our lesson in Envision. If you look at this parallelogram, right, this is a base and that's the height. So a parallelogram can be decomposed into 2 identical triangles. So how can we use the formula of the parallelogram to find the area of a triangle? I want you to look at this. So it was cut into half, right? So obviously from there, we could figure out the formula of a triangle. We also know that the area of a parallelogram is base times height, right? So that is the area of a parallelogram. We could also create a diagonal on the parallelogram to divide it into two identical triangles. Let's see if we could prove that these two are identical. Let's see how it's gonna work. Let's look if it flips and exactly the same thing. So break into rotate it and becomes one regular triangle. So with that, we could say that the formula could be base times height. And since we break it into two, we could say the formula for the triangle is base times height divided by 2. Here we could say that the area of a parallelogram is base times height and then we could say that the area of the triangle could be 1/2 of the base and the height because we cut them into 2. So that's how we figure out that the area of a triangle, no matter what kind of triangle it is, it's gonna be 1/2 base times height because always could cut a rectangular shape, a square, a parallelogram into half to create area of a triangle. Let's look at our example number 2. The side of the birdhouse is in the shape of a right triangle. What is the area of the side of this birdhouse? So let's look at the lesson in Envision. So let's look at this problem. The side of the birdhouse is in the shape of the right triangle over here. So what is the area of the side of the birdhouse? So to begin with, this is half of that square, right? Because it's 8 times 8. So we already know in the first example that the formula for a triangle is base times height, and we divide it by 2 because we're only using half of that square. So now the area will be 8 times 8. We divide it by 2. And we know that 8 times 8 is 64. And we divide it by 2 again because we're only taking half of the entire square. And we all know that 64 divided by 2 is 32. We always have to remember the units of measure that we have, or else we'll always get points off when we do the test. So inches and inches, since we're doing a square units, so we are doing a square inches. It's just like 8 inches times 8 inches. So inches and inches is square inch. Alright? So our answer is 32 square units. Or inches in this case. Let's try one more example. Alright? Here's another one. Killen drew a triangle shown below. What is the area of this triangle? Just by looking at it, you could solve it in 2 ways. Alright, but let's look at the lesson that was given to us in Envision, and we'll take it from there. Let's look again at this example. So Killen drew a triangle shown below, right? So what is the area of a triangle? You will say, what's the height? What's the base? We always have to remember that the height will always be represented by the angle, the right angle that is present in that picture. We usually look at the height where it is perpendicular to the base. And it's always represented by the right angle because that tells you that it stands up straight. In this case, we could solve this problem this way. This could be our height, which is 8 feet, and that would be the base. And you know that that's the height, but that's a perpendicular to the base, and that makes the right angle. Alright, so we could go all the way down over here, even to close over here. If you want to label it here, that would be your height. Okay? We could also solve this problem by substituting the values of those variables or corresponding variables that represents by using the formula, right? So area is 1/2 base times height. So in this case, area will be 1/2. Okay, our base will be 10, so we could put 10 over here, and then our height is 8. Then we'll do our calculation. That gonna be 10 times 8 gives you 80, times 1/2 or divided by 2, that gives you 40. And we know that we're using area, so our unit is of square feet, because we're gonna be multiplying 10 feet times 8 feet. Okay, that's your height. So for this example, our answer is 40 square feet, which we gonna use it this way. So let's see if we could solve it in the other way, where our base is this one. Let's look at the other side of this picture. All right, looking at the other side of this triangle, remember the beginning, it was labeled this way, that the height is right here, where the triangle meets to the base, which is 16, and the height is 5. We know that that's the height because of that right angle that represents there. Again, substitute the value for the equation or for the formula. We have 1/2. This time our base is 16 and our height is 5. We also know that 16 times 5 is 80. So 80 times 1/2 or divided by 2, we still get 40. And our units is still square feet. So no matter what way you want to solve it, either you solve it this way with looking for the height from here. Okay, oh, that makes it straight line. So it doesn't matter if you go it this way and your base is this, it still will work, because you are only solving the same figure. It's just you look at it in two different perspectives. All right, this one is looking exactly where your triangle is. The other one is looking where it's the other height of that triangle. Alright guys, so with that said, I want you to go to Google Classroom. I want to explore the other equations that is given to that and just go back to the examples that we learned today. So now you could go to your Google Classroom, check the work that I have given you for Envision, and good luck solving for triangles. Have fun, even though it's not fun for others, but let's have fun, guys, doing their work, and it is really, really nice to try. All right, there's no harm in trying. Again, thank you. Stay safe, and let's await for the next lesson that we're gonna have. The next one will be trapezoid. Yay! All right, have a good day, everybody, and I'll see you again tomorrow. Bye bye.